Ever wonder what's going on in the world above us? From the air we breathe to the weather we experience every day, it's all connected. Today, we're diving into the atmosphere, heat transfer, and what makes weather tick. The atmosphere is Earth's protective blanket of gases, mostly nitrogen and oxygen, with small amounts of carbon dioxide and water vapor. It's not just about keeping us alive. It also regulates temperature, shields us from harmful radiation, and makes weather possible. The atmosphere is divided into distinct layers: the troposphere, where weather happens; the stratosphere, home to the ozone layer; the mesosphere, where meteors burn up; the thermosphere, where auroras and satellites exist; and the exosphere, which fades into space. Now, let's talk about how heat moves. There's conduction, where heat transfers through direct contact; convection, where warm air rises and cooler air sinks; and radiation, where heat travels through electromagnetic waves. Then there's insolation, the sunlight reaching Earth; and compression heating, where descending air warms up as it's squeezed by increasing pressure. What about the greenhouse effect? It's how Earth stays warm enough for life. The sun sends shortwave radiation to Earth, which absorbs some and reflects the rest as longwave radiation. Greenhouse gases like carbon dioxide, methane, and nitrous oxide trap that heat and send it back to Earth. While this natural process keeps us warm, too much of it can lead to global warming. So, what's the difference between weather and climate? Weather is what's happening right now, like a sunny or stormy day, while climate is the average of those conditions over decades. Weather includes several elements, each measured with specific tools. Temperature is checked with a 6 thermometer, precipitation with a rain gauge, wind speed with an anemometer, and wind direction with a wind vane. Air pressure is tracked with a barometer, humidity with a hygrometer, cloud cover is observed visually, and sunshine is recorded with a sunshine recorder. To get accurate readings, meteorologists use a Stevenson screen. It's a white, louved box that protects instruments like thermometers and hygrometers from direct sunlight and other factors, ensuring precise measurements. Temperature decreases with altitude, dropping 1 degree Celsius for every 100 meters, a pattern known as the normal lapse rate. Occasionally, a temperature inversion occurs, where warmer air sits above cooler air, reversing this trend. Several factors influence temperature. Latitude plays a key role, as the Earth's curvature causes sunlight to be most direct near the equator. This concentrates heat in smaller areas, while higher latitudes spread sunlight over larger areas, resulting in cooler climates. Distance from the sea also affects temperature, as water heats and cools more slowly than land. This creates coastal breezes. During the day, warm air from the land rises, drawing in cooler sea air, while at night, the ocean retains heat and sends warm air back to the land. Prevailing winds carry temperatures from their origin, bringing either warmth or cold to regions. Similarly, ocean currents influence coastal areas, with warm currents raising temperatures and cold currents lowering them. Altitude is another factor, as higher elevations have thinner air that retains less heat. Conversely, lower altitudes experience higher temperatures due to denser air that traps heat more effectively. The nature of the surface also matters. Darker surfaces absorb more heat, while lighter ones, like ice or snow, reflect it. Longer daylight hours mean more heating of the surface, resulting in higher temperatures. Finally, aspect, or the direction a slope faces, affects how much sunlight it receives. In temperate zones, slopes facing the sun are warmer, with north-facing slopes in the northern hemisphere and south-facing slopes in the southern hemisphere receiving the most sunlight. Air pressure is the weight of the atmosphere exerted on the Earth's surface. It varies with altitude, temperature, and the Earth's rotation. At higher altitudes, there are fewer air molecules, resulting in lower pressure. At lower altitudes, air is denser and exerts more pressure. Temperature influences pressure by affecting air density. Warm air expands and rises, lowering pressure, while cooler air contracts and sinks, increasing it. The Earth's rotation creates global pressure belts as air moves between high and low-pressure areas. This movement drives winds and shapes weather patterns. The Coriolis effect adds a twist to this process. causing winds in the northern hemisphere to curve to the right and those in the southern hemisphere to curve to the left. Humidity refers to the water vapor in the air and is expressed as either absolute humidity, the actual amount of water vapor, or relative humidity, the ratio of water vapor present to the maximum it can hold. When air cools to its dew point, it becomes saturated and condensation occurs. Condensation requires sufficient water vapor, particles for moisture to cling to, like dust or salt, and a temperature below the dew point. Dew forms on cool, clear nights when the ground loses heat. Fog develops near the ground as air cools and condenses, while frost occurs when water vapor directly forms ice at freezing temperatures. Clouds, formed by condensation, come in various types: cirrus, wispy and high altitude; cumulus, puffy, with flat bases and rounded tops; stratus, flat, layered sheets; nimbus, rain clouds; alto, clouds at medium heights. Precipitation occurs when water droplets or ice crystals become too heavy to remain suspended in clouds, falling as rain, snow, hail, or drizzle. Rain can take different forms. Orographic rain happens when moist air rises over mountains, cooling and condensing on the windward side, while the leeward side often remains dry, forming a rain shadow. Frontal rain occurs at the boundary between warm and cold air masses, where the lighter warm air rises over the denser cold air. This process forms clouds and results in rain. In convectional rain, the sun heats the ground, causing rapid evaporation. Moist air rises, cools, and condenses into heavy rain clouds, leading to intense rainfall in nearby areas. Other forms of precipitation include drizzle, which consists of fine droplets often from stratus clouds; snow, formed when water vapor freezes into ice crystals; and hail, which develops in storm clouds as raindrops freeze, grow, and eventually fall to the ground. If you enjoyed this video, don't forget to like and subscribe to our channel. Check out the rest of the videos in our geography series to learn more.